Hi, today I'm going to do a really quick review of the terms even, odd, and a one-to-one function. These are terms that you learned in Algebra 2, and so we're reviewing them this year and using them in pre-cal. So the first thing that we're going to talk about is how to classify a function graphically. If you're classifying a function graphically, then it stands to reason you should be looking at the graph. So we're going to use this example right here. You can see it's quadratic. You can see the main points that we've plotted there. And basically, to classify a function graphically as an even type function, it has to be symmetric with respect to the y-axis. So in essence, what that means is if I take this quadratic and I fold it in half like that on top of the y-axis, everything would match up. This point here is going to be on top of that point there. That point there is going to be on top of that point there. And so everything is going to be lined up. We can say that this is classified by its type of symmetry. Okay, so when I say even function, that is a result of knowing about the symmetry of the graph. Okay, so in this case, it is a quadratic, and oftentimes students will say, oh, well, it's quadratic, so it has to be symmetric. But look at where that the axis of symmetry on the quadratic graph is. It's right here. So if I take this side and I fold it up with this side, there where it's symmetric, it's going to be symmetric right here and not over here on the y-axis. So that is not an even classified function, even though it does have that even power in it. We also learned how to classify functions algebraically. And so what we did is we took a function and we replaced every x in the function with a negative x. So I inserted a negative x here and a negative x here, and I simplified it. So a negative x to the power of 2 would be a positive x squared. A negative x to the power of 4 would be a positive x to the fourth. Then we have that negative in front, so we end up with this particular equation after we've made that negative x substitution. And what I hope you remember then is when you see this original function and you make that substitution and you still see the original function, then we know that it can be classified as an even type function. And so the rule was plug in a negative x and get the original function out. So what are some of the parent functions from Algebra 2 that we studied that are even classified functions? Well, we have the absolute value, we have the quadratic, we have the rational even, and isn't that convenient? The name is right there in the name of the function itself. And then we could do powers that are even, like x to the fourth, x to the sixth. So those are some of the ones that we looked at last year. Now let's talk about odd classified functions. Odd classified functions graphically, we'll start with graphically again, means that I have my function here and it is symmetric with respect to the origin if it has odd classified, or it's an odd classified function. So sometimes we call that rotational symmetry, sometimes it's called origin symmetry. But really, here's the nifty just visual for me, is if you spin the graph at the origin 180 degrees, you see the same thing you started with. So here's my graph. You can see the word odd there, so you'll be with me. So I'm taking it and I'm spinning it 180 degrees, turning it upside down. And look, I see the same thing I started with. That means it has rotational symmetry. You can see we rotated it because that word is in a different spot. So that's just a really quick visual way that you can address that. So look at this one. It is the same line graph, but you can see it's not at the origin. So remember, we're spinning it with respect to this origin point right here. So if I do that, then I can see I'm not seeing the same graph because the one we had before was up here. So that means this doesn't have odd, it can't be classified as an odd type function because it doesn't have origin symmetry. And so that's the way graphically that you can tell odd classified functions. Again, do not confuse with the classification of even and odd with the type of symmetry it has. You have to look at the symmetry and then you can determine how you can classify it, if you can classify it all. Like this one, even though this still has a power of 1, which can be odd, it's not going to have odd classified symmetry. Then we also learned to look at this algebraically. And so here's my function algebraically. Again, I replace every x with a negative x. So everywhere there's an x, you get your negative x. And then I have negative x to the third power is negative x cubed. And I have a negative x here, but that's a negative negative, so that makes that a positive. So this is what I get when I simplify. That is definitely not the original function, so we can tell right away it's not even. But what happens if we factor a -1 out of both terms? We pull the -1 out in front, that makes this x cubed, and that makes this -x. Can you see that this right here is the same thing we started with? Okay, good. That means after I substitute -x and I can factor out negative, I should be the negative of the original function, or the reflection of the original function, and that's what the definition tells us. If that's true, then algebraically we can classify it as an odd type function. So I plug in the -x, I pull the negative in front, and I should get the negative times whatever that original function is right here. So that's how we did algebraically. So what graphs last year did we study in Algebra 2 that had odd classification or types of functions? We looked at the linear, we looked at the cubic, we looked at the cube root, and again, the rational is nice and handy for us because the name, it has it in the name, rational odd. So those are the ones from last year. The last thing I want to kind of go back over from Algebra 2 is what it means to be a one-to-one function. So when we're looking at one-to-one functions, there's a lot of things to think about, but basically the definition says for it to be a one-to-one function, every x value has one distinct y value, and every y value has one distinct x value. In other words, every element of the range of the function pairs with only one element of the domain. This means that the function will produce answers that never repeat. The function will produce different answers for every input. And there's where we started looking at the different line tests last year. And we said that if a function passes both the vertical line and the horizontal line test, then it is classified as a one-to-one function. And so the vertical line test, remember, means you draw vertical lines all over your graph, and if it never intersects the graph twice and it passes the vertical line test, then that original function, or that original graph, is a function. If you apply the horizontal line test, that's where you draw horizontal lines across the graph, and if it never intersects the graph twice, then it tells you that the inverse graph of that original function will also be a function. In other words, if I invert it and I trade my x and my y's, and I look at my new graph, that's going to pass the vertical line test. So if the original graph passes both, then we know a little bit about it. And this becomes kind of handy, especially if we don't necessarily want to know the graph itself, but we have enough graph knowledge to understand what the graph behavior looks like. So we spent so much time in Algebra 2 learning how and what those graphs look like, so you have a little base knowledge there. So let's look at a couple of examples. So let's look at this quadratic, which is right here. And we can see that if I draw a vertical line test anywhere on here, it's never going to fail the vertical line test because that vertical line is only ever going to intersect that quadratic one time. So that tells me this is a function, which we already know because we studied a lot about parent functions in Algebra 2. All right, so now if I start drawing horizontal lines, so I'm drawing lines across it right here, can you see that that intersects it twice? That means it fails the horizontal line test. If it fails the horizontal line test, when we invert this and look at what the inverse would look like, we can see the inverse would fail the vertical line test. So by knowing that the original fails the horizontal line test, we know that when we invert it without any kinds of restrictions, it would fail the vertical line test, and that this inverse would not be a function. Sometimes we can restrict it to make it be a function when we invert it. For instance, we could say, let's just graph from 0 to infinity, and so we would only see that graph. So when we invert it over here, we would only see half of this graph, and then it would pass the vertical line test. But if it doesn't, to begin with, it's definitely not going to pass the test. So knowing about the two line tests on the original tells you information about the inverse and whether the inverse would also be a function. All right, so let's look at this one. So we have this function right here. So the first thing is, does it fail the vertical line test? Can I draw vertical lines here all day long and be certain that it's not going to fail the vertical line test? And the answer should be, yes, we can. All right, and then I start looking at horizontal line tests. So I do the horizontal line test and start drawing lines back and forth this way, and I can see it's never going to intersect that graph more than once, so it passes the horizontal line test. And then I can say, since it passes the vertical line test and it passes the horizontal line test, then this function is classified as a one-to-one function. And we shouldn't know that anyway because we knew this was cubic. So even if they had given us the equation, maybe they said what is y equals x cubed 1 to 1? Well, you know a little bit about the graph, right? You know it's going to pass the vertical line test because it's a function, and that's what we studied in Algebra 2 were all those parent functions. And then you can visualize what that graph looks like and think about those horizontal lines and know it's also going to pass that. And since it passes both tests, then we know that it's classified as a 1-to-1 function. All right, so that's just a real quick overview of even, odd, and 1-to-1 functions, things that we studied in Algebra 2. Thanks, guys. Bye.